Okay, let us start. Last week, we learned about calculating velocity. So if you have measured, if you are given the position of a moving object as a function of time, you know how to, you know where it is at each moment in time, then you can find its velocity. And we discussed the concept of exact velocity at each moment in time. And then, based on that, we developed the concept of the derivative. Okay? Now, this week, we will learn how to find the position of a particle if you know its velocity. So, you have recorded the speed at each moment. For example, you are driving a car, and whenever you look at your speed meter, it tells you how fast you are driving at that moment. Okay? You can record that. You know, at 1 o'clock you were driving with 100 kilometers per hour. At 1 second after 1 o'clock, you braked a little bit, and now you are at 98 kilometers per hour, etc. Of course, this thing can also be done automatically. Your speedometer can record your speed. So, suppose you have measurements of the velocity at many moments in time. And you can list those things, velocity versus time. You can make a table, or you can have a graph. Here, the line here is your velocity measurements as a function of time. And in particular, if you have made the measurements at intervals delta t, okay, these are the actual values of the measurements you made, and you can graph them. Okay? Now, if your object started motion at t equals 0, and at that moment you know its position, you call that x0. And you want to find out where your car or your object is at x equals delta t seconds later. Okay? So the new position equals the old position plus how much it went, the distance gone, in the next moment, delta t. From 0 to delta t. So what is that distance? If you know the velocity of an object, it's moving at this velocity, and it's moving for some time, delta t. How do you find the distance? Okay, so you write a velocity. What velocity do you write? Well, you have just measured the velocity at time t equals 0. That's the velocity you know. Okay, so you write that velocity. Okay? Is this clear? Very simple. Now, if you want to find the position at time 2 delta t, this is going to be the position that you already calculated at time delta t plus a velocity times the new time interval, right? What velocity shall I write here? What velocity? Well, the latest one that I just measured, which is the velocity at let me call that T1 times delta T. So here is what I'm calling T1. This is T2. This is T3. All right? Well, this is nothing but the initial position plus the little step of distance I went in the first time interval delta t plus okay, and clearly if you proceed that way, this is just the obvious way to calculate how much distance is gone. Okay, I start from this position, then in the first time delta t, I move this much. In the second time, maybe I'm faster, I move this much. In the third time, in the fourth time, etc. You just add every step in meters, and every step in meters is just the last velocity, almost present current velocity, times the length of time. So the total distance gone at some later time t sub n, the nth time that I measured, is simply equal to h0, the position I started from, plus now we have some new notation here, and I'll introduce the notation now. I'm introducing a new term, a mathematics term. This means sum from n equals 0 to n equals n minus 1. Let me now go over that a little bit. Okay. For example, if I want to find the velocity, the position at time t5, that's the fifth time that I measured. T5 is simply 5 delta t. Okay? What is that equal to? It's equal to x0, that was my original position, plus v0 delta t, plus v1 delta t, plus v2 delta t, plus v3 delta t, plus v4 delta t. That's it. I don't have V5 because V4 was the last measurement until I got to the 5th position. Okay? Instead of saying this all the time, add all the v, t, delta t from the first time until the time one before the last, add, okay? The short way of saying that is to introduce a mathematical symbol. This one, sum, okay? That symbol is simply the Greek letter sigma. Sigma is the same letter as S. It comes from sum because in most Western languages, addition is with some word starting with S. Okay, so sigma is just Greek letter. It's just a reminder that you are adding things. Okay, is this clear? Now let me come back to this graph and see what I have calculated. Well, V0 times delta t, well, this is V0.